The MiG-25 Foxbat is a Soviet-era supersonic interceptor and reconnaissance aircraft developed by Mikoyan-Gurevich. Notable for its high speed and altitude capabilities, it was one of the fastest military aircraft to enter service, capable of reaching speeds over Mach 3. Here are some key details about the MiG-25. Design and development. Designed to counter the perceived threat from high-altitude American bombers and reconnaissance aircraft, like the XB-70 Valkyrie and SR-71 Blackbird. Performance. The MiG-25 is known for its incredible speed, over Mach 3.2, and high-altitude performance, capable of operating at altitudes up to 27,000 meters, 89,000 feet. Variants. The MiG-25 has several variants, including the MiG-25P, Interceptor, MiG-25R, Reconnaissance, MiG-25RB, Reconnaissance Bomber, and MiG-25PU, Trainer. Operational history: entered service in 1970 and saw extensive use by the Soviet Union, as well as several other countries including India, Iraq, and Syria. Known for its role during the Cold War and various conflicts in the Middle East. Retirement and legacy. While many MiG-25s have been retired, some are still in limited service. Its design influenced later aircraft, such as the MiG-31. Design and development. The MiG-25 was developed during the 1960s as a response to the need for an aircraft capable of intercepting high-speed, high-altitude threats posed by Western aircraft. The development focused on achieving unprecedented speed and altitude capabilities, resulting in a unique design characterized by large, powerful engines and a robust airframe capable of withstanding the stresses of supersonic flight. Performance speed. The MiG-25 can reach speeds exceeding Mach 3.2, about 3,400 km/h or 2,100 miles, although sustained speeds above Mach 2.8 could cause damage to the engines. Altitude. It can operate at altitudes up to 27,000 meters, 89,000 feet, which was instrumental in its role as a reconnaissance aircraft, allowing it to fly above the reach of many surface-to-air missiles and interceptor aircraft of the time. Range. It has a combat range of approximately 1,860 kilometers, 1,160 miles, and a ferry range of 2,575 kilometers, 1,600 miles. Variants: MiG-25P, Interceptor. The primary interceptor variant, equipped with radar and missiles designed for air-to-air combat. MiG-25R, Reconnaissance. Designed for high-speed reconnaissance missions, equipped with cameras and electronic intelligence equipment. MiG-25RB, Reconnaissance Bomber. A dual-role variant capable of conducting both reconnaissance and bombing missions. MiG-25PU, Trainer. A two-seat trainer variant used for pilot training and conversion. Operational history. Cold War. The MiG-25 played a crucial role during the Cold War, with its high-speed reconnaissance missions often flying over adversary territories to gather intelligence. Middle East conflicts. It saw extensive use in the Middle East, notably by Iraq during the Iran-Iraq War and the Gulf War. The aircraft performed various roles, including reconnaissance and interception. Notable incidents. One of the most famous incidents involving the MiG-25 was the defection of Soviet pilot Viktor Belenko to Japan in 1976, which provided Western intelligence with valuable information about the aircraft's capabilities and technology. Retirement and legacy. Soviet Union, Russia. The MiG-25 was gradually phased out of service in Russia by the late 1990s and early 2000s, replaced by more modern aircraft like the MiG-31. Other countries. Some countries, such as Syria and Algeria, continued to operate the MiG-25 into the 21st century, albeit in limited numbers. Influence. The design and technology of the MiG-25 had a significant impact on subsequent Soviet aircraft, particularly the MiG-31, which inherited its speed and altitude capabilities but with improved avionics and weaponry. Technical specifications: crew, 1, single seat, or 2, trainer variant. Length, 23.82 meters, 78 feet 2 inches. Wingspan, 14.1 meters, 45 feet 11 inches. Height, 6.10 meters, 20 feet 0 inches. Max takeoff. Weight, 36,720 kilos, 8,950 lbs. Engines, 2X Tumansky R-15B 300 turbojet engines. Armament, typically 4 air-to-air missiles, R-40, R-60. Design features, structure. The MiG-25 structure is largely made of nickel-steel alloy, with some titanium and aluminum components. The choice of materials was driven by the need to withstand the high temperatures generated during supersonic flight. Aerodynamics. The aircraft features a high-mounted swept-wing design with large vertical stabilizers and powerful control surfaces. This design allows for stability at high speeds and altitudes. Cockpit. The cockpit is equipped with basic avionics compared to modern standards, reflecting the era of its design. It includes a primitive but effective radar system in the interceptor versions. Engines Tumansky R-15B 300 turbojets. The MiG-25 is powered by 2 Tumansky R-15B 300 turbojet engines, each producing 100 kN, 22,000 lbf of thrust. These engines are optimized for high-speed performance but have a relatively short operational lifespan due to the stress of supersonic flight. Fuel consumption. The engines are extremely thirsty, which limits the aircraft's range and requires careful fuel management, especially during high-speed operations. Avionics and weapon systems. Radar. The MiG-25P interceptor variant is equipped with the Smerch-A Foxfire radar, capable of detecting targets at long ranges but with limited capability against low-flying or small targets. Weapons. The primary armament consists of 4 air-to-air missiles. The typical loadout includes a combination of R-40, AA-6, Acrid missiles with both radar-guided and infrared-guided versions for flexibility in combat scenarios. Reconnaissance equipment. The reconnaissance variants carry an array of cameras and electronic intelligence, ELINT, sensors to gather photographic and electronic data from high altitudes. Operational history and tactical use. Interception. The MiG-25P's primary role was to intercept high-speed, high-altitude bombers and reconnaissance aircraft. It was designed to climb rapidly to engage targets at extreme altitudes. Reconnaissance. The MiG-25R and its subvariants excelled in reconnaissance roles, providing valuable intelligence by flying high and fast enough to evade most contemporary air defenses. Combat. While not primarily designed for dogfighting, the MiG-25's speed and altitude capabilities allowed it to engage and disengage from combat rapidly, making it a formidable adversary in the skies. Notable incidents and deployments. Victor Belenko's defection. On September 6, 1976, Soviet pilot Victor Belenko defected to Japan with a MiG-25P, providing the West with a unique opportunity to study the aircraft's capabilities and design. This incident revealed both the strengths and weaknesses of the MiG-25, leading to improvements in Western aircraft and tactics. Middle East conflicts. The MiG-25 saw significant use in conflicts such as the Iran-Iraq War, where it was employed for both reconnaissance and combat missions. Iraqi MiG-25s were reported to have engaged in combat with Iranian F-14 Tomcats and other aircraft. Operation Desert Storm. During the Gulf War, Iraqi MiG-25s attempted to counter coalition air superiority, but were largely outmatched by more modern and versatile aircraft, such as the F-15 Eagle. Retirement and legacy replacement. The MiG-31, Foxhound, a successor to the MiG-25, was developed to address the shortcomings of the Foxbat, incorporating more advanced avionics, better maneuverability, and a greater range. Current status. While most MiG-25s have been retired from service, a few remain in limited use with some air forces, primarily for reconnaissance roles. Influence. The MiG-25's design philosophy influenced subsequent generations of high-speed interceptors and reconnaissance aircraft, emphasizing the need for speed and altitude in certain strategic roles. Technical challenges and limitations. Maneuverability. The MiG-25 is not highly maneuverable at lower speeds or in dogfight scenarios, reflecting its design focus on speed and altitude. Engine longevity. The high-performance engines have a relatively short operational life, necessitating frequent maintenance and limiting sustained high-speed operations. Avionics. The avionics and radar systems, while advanced for their time, are outdated compared to modern standards, limiting the MiG-25's effectiveness in contemporary air combat scenarios.